Okay, now find f of g of x and g of f of x for each of the equations and determine if they are inverse. So what is going on here? Well, f of g of x, this is the same as what we just did before, fog, and this is the same as the other one, Goff. We're just plugging in this equation into that for the x. So let's do that first. F of g of x, so we're plugging in g into f. So here's g, I'm plugging this whole thing into x. So I got negative 6 times 1 over 6 times x. Okay, so I plug that in for x. Let me solve. Negative 6 times 1/6 is negative 1, and then we just have x. So negative 1x, that's for that. For this, I'm going to do g of f of x, so I'm plugging in f of x into g of x. So here's f of x, I'm plugging in this whole thing into the x here. Okay, so 1 over 6 times negative 6x. Same thing. 1/6 of negative 6 is negative 1, and then we got x. Are they inverse? How we tell is if these two values are equal. If f of g of x equals g of f of x, then we know that they're inverse. If they're not equal, then they're not inverse. Okay? So if this was negative x and positive x, they wouldn't be equal, so we know it's not inverse. But since negative 1x is the same as negative 1x, it's inverse. Okay? So let's do the same thing here. F of g of x, plugging in g of x in for the x here. 1/2 2x minus 10 plus 5. Simplify, 1/2 of 2x is 1x. 1/2 of negative 10 is negative 5. We've got the plus 5. Negative 5 plus 5 is 0. All I'm left is x, or 1x. Same thing. Now, do the other one. G of f of x. I'm plugging in f of x in for the x of g. So 2 times 1/2 x plus 5 minus 10. And I think you already know what's going to go on. 2 times 1/2 of x is 1x. 2 times positive 5 is positive 10 minus 10. These cancel out, and I'm left with x. And you'll see that 1x is equal to 1x, so they are inverse. Both of these are inverse. If you can spell inverse. There you go.